Hello friends, today we have an interesting topic on data structure and application laboratory 17 CSL 38, that is binary search tree or BST, which is very commonly used in many of the applications of data structures, and this is a program number 10. So in this particular program we are going to construct a binary search tree and search for an element, and we are going to have traversals of the tree, that is in order, pre-order, post-order. So what is a binary tree here? So the binary tree is a tree in which the root node will have this is the root node, and this is the left subtree, and this is the right subtree. So the key element of the left subtree will be always less than the root node key, and the right node key will be always greater than the key node of the root node. So here this will be recursively followed. That is, two rules are important to construct a binary search tree. So before we exactly move into the basics of binary search tree, so myself Shanti DL, Assistant Professor, Department of ISE, BMSIT and M. Let's move on to the theory of BST, and then we'll see the implementation of BST. The question is like this: design, develop and implement a menu-driven program in C for the following operations on binary search tree of integers. So the first option we have is create a binary search tree of n integers. So these are the integers given. So based on these values and the input, we need to construct a binary search tree. And the second option, traverse the binary search tree in order, pre-order and post-order. And third option we have is search the BST for a given element key and report the appropriate message. So this is the operations which we can perform on binary search tree, which minimizes the number of searches on the set of elements because of its binary search tree property. So what is the binary search tree property lies here. So in there are variations in the binary search tree definitions. So some books, some literature says differently. So here this is the basic definition we have. A binary search tree is a tree in which all nodes follow the below mentioned properties. The left subtree of a node has key less than or equal to its parent node's key, and the right subtree of a node has a key greater than or equal to its parent node's key. So that means recursively each node of the binary search tree follows these two properties. Whether it is a left subtree or a right subtree, this has to follow this property. So sometimes they'll consider it as the key is less than only, and this is sometimes also can be considered as less than or equal to its parent key. So thus the binary search tree divides all its subtrees into two segments, left subtree and right subtree, and can be defined in a short form as left subtree keys are, that is, root node key is always greater than the left subtree keys and less than the right subtree keys. So here, for example, we can see this here. The BST is each of the node, when we consider, it is following the BST property. So when we consider the first node, which is less than the parent node, the parent of this node is the node, this one, that is 14. Tens, the node with the value 10 is the left child of the node with the value 14, and 19 is the right child of the node 14. And similarly, if you move upward towards root, here this is the root node we have. So when you check the property of binary search tree, so 27 is greater than all the nodes of the left subtree of the given BST, and when you check the right subtree of the given tree is greater than the root node. And similarly, when you move down to the right subtree, we can see that the left node of that particular subtree is less than the root node and the right node is greater than the root node. So this property is forwarded till to all the levels of the binary search tree. So what are the operations which can be performed primarily on the tree are search for an element in the tree, insert an element in a tree, and the three traversals. One is traverse the tree in pre-order, in order, and post-order. Consider, for example, how we are going to construct the binary search tree. Suppose say I want to insert value 50 and say insert. So your first node is created. So if I want to go for further, I want to create a node with value 69. So it is going to create the node as the right node of 50. And similarly, if I enter the value which is less than 50, so it is 45 I consider. So this will be added to the left of the root node. And similarly, if I keep on entering the elements, so which are like this, so that is 60 is the next element I want to insert. So its place is first it checks in root. If this is greater than, it will move on to the next node and it checks. Now this is the root node for particular one. It checks the value of this node and it sees that if it is less than the root node, it adds that new node as the left node or else it adds as the right node. So if I consider the left next value is 49, so where it has to be inserted is first it checks with whether the 49 is less than 50. So if it is less than, it will go to the left subtree and checks the root node here. Now my root is this one, so it checks with 49 with 45 with 49. So 49 is greater than 45, so it creates as a 49 as a right child of 45. So this is what happens here. So first check in the root which is less than the root node and check again with the next node, and if it is greater than this, so insert at the right as a right node. Let's consider if I add 20 as the node, so it has to be inserted as the left node of the 40. So this will be inserted in this way. So check with 40 and check with 45. So because it is less than 45, insert as the left node. Similarly, if I want to go for the node with value 100, first it checks with 50 and checks with 69 because the value is greater than 69. So it will be added as the right node of the 69. So this is how the binary search will be constructed. That means each time we insert an element, it checks whether the element is less than the root node or greater than the root node. If it is less than, it will be inserted as a left child of the root node. If it is greater than the root node, it will be inserted as the right child of the root node. This is recursively followed for all the elements, whether it is in the left subtree or in the right subtree. Let's consider if I want to find an element, whether it is present or not in this particular binary search tree. So if I enter the value, so it will checks. So my search here, it is minimizes because based on the value, it will either check in the left subtree or in the right subtree. No need to check the entire set of nodes in the binary search tree. So consider my value given to find is 60. So first it will check at the root and then it goes to the right subtree and it finds the element at the right subtree and the value is found. So if I say the value 50, so it check value 50. So this is first node itself. So I found at the first instance itself, right? So here if I say one more element, like 15, it will searches only in the left subtree of the binary search tree. So check at the root and then check at the left subtree. So if the element is not found, it will report that element is not found. Consider the tree traversals. So this is a tree. So this is a root node and this is a left tree and this is right subtree. So the way we are visiting the root, left subtree and right subtree, based on that we have three order of traversals. One is in-order traversal, pre-order traversal and post-order traversal. So in the case of the in-order traversal, the left subtree will be traversed recursively and left subtree will be traversed recursively and root will be traversed, visited, and then right subtree will be visited recursively. So here for simplicity we have considered only one node at the left subtree and the right subtree. So here first left subtree will be visited, that is B, and then root will be visited, that is A, and then right subtree will be visited in the recursive order, that is C. Similarly, when we go to the order traversal, that is pre-order traversal. So in this pre-order traversal, what happens? The root will be visited first and then left subtree will be visited recursively in the same root left right and right subtree will be visited in the recursive order in the root left right order. So here when we consider root is A will be printed and the left subtree is B and right subtree is C. So if A, B and C are again consist of children, that also should be traversed in this order only, that is root left subtree and right subtree in this order only. So then the next one we have is a post order traversal. That means here the left subtree will be visited recursively and then right subtree will be visited recursively and then root will be visited. That means here the left subtree is B, the right subtree is C and the root is A. So B and C also should be visited. If it contains the children, it also should be visited in this order only, that is left subtree, right subtree and then root. So these are the three traversal methods we have for traversing the tree. So now we move on to the implementation. So each node of the list consists of three parts. One is the data field, the other one is linked to the left child and the other part is linked to the right child. So here we are using the linked list for construction of binary search tree. So here the left pointer contains the address of the left child and the right pointer contains the address of the right child. So this follows similarly until we reach the leaf node. A leaf node is one which doesn't have any child. So if it contains the left child and the right child, so this is the intermediate node and the left and right will become the children of this particular node. So that's why, so in this structure we have three fields. One is data field, the other one is left child which holds the address of the left child, then the other one is right pointer which holds the address of the right child. So we can see here we have created a BST with a node and the create tree. In the create tree we are passing the first node's address and the data to be filled. So if the node is null, that means if no nodes are there in the tree, so then we are going to create a new node and that becomes the first node. So here node is equal to temp. So for temp we are going to allocate the memory and then temp data will be put here in this particular location and temp left and temp right is equal to null. So initially if this is the only node I have created, then left child and right child won't be there, so that we are going to make it as null and return that node as the first node of the tree. If the tree already contains some nodes with it, then we have to check before insertion which particular location the new node has to be created. So here we'll check with the data of the node which we are going to create and the root nodes data. So here if the data which we are considering currently is less than the root node data, then the node will be made as the left child. So recursively we are going to call a create tree left node as the address and data to which we want to create the node. If suppose this is not true, if the data is greater than the root node value, greater than or equal to, so here we are going to consider the root greater than or equal to, so then the node will be inserted at the as a right child to the root node. So it is again calling a create tree function recursively. Consider the in-order binary search tree. If node is not equal to null, that means if the root node is not equal to null, we are going to call a function in order. So the left child will be called recursively in order in this particular one and print that particular node value and then call the recursively the right child of the tree. So in our case, so if we consider the left node of the will be left subtree is this and right subtree is this. So this tree will be visited recursively the in order. So in order will be called recursively for this particular subtree and visit the root node and then this is visit the root node and visit the right subtree in recursive order in order. So here if we consider in order traversal of this particular tree, the values printed will be like this. So first we are going to visit the left subtree and then we are going to visit the right subtree and then we are going to visit the first left subtree and the root and then the right subtree. So this is the order in which the in order traversal will be displayed. So that means when we are traversing the in order, the left child will be visited first and then the root and then the right child. The next we have is a pre-order traversal. In the case of pre-order traversal, first the root will be visited and then the left child will be visited and then the right child will be visited. So this is going to happen if node is not equal to null. That means there are some nodes existing in the tree. So then we are going to follow this order. So that is pre-order. So one more function we have here is the search function. So in the search function, it is going to be passing the root node address and the data to be searched. If the node is not equal to null, that means we have some nodes. Through all those nodes we need to search. If the node is equal to null, that means the tree is empty. So in this particular case, if the given data is less than the root node data, then recursively we need to search in the left subtree, that is search node left comma data. That means we are calling the function recursively in tree. If the given data is greater than or equal to the root node, then we need to search in the right subtree of the tree. So we're going to call search recursively by passing the root as a root node right as the starting address and the data to be searched. So if the entire thing, if the node is present in the root itself, so that will be printed in the element found. If not, the element is not present. So that means if the node is null, the root is null, or if we have checked all the left part or left subtree or right subtree of the BST, if the element is not found, we are going to write it as a node not found. So here we are using the recursive search operations. If the data is less than the root node, so recursively we're going to search the left subtree. And if the data is greater than or equal to the root node, then we are going to search the right subtree recursively. So in the main program, we are going to come across all the functions which we have studied till now. That is, we are going to create a root node, and initially we are making it as a null. The options available are insert in a binary search tree, search an element in the binary search tree, delete an element in binary search tree, traversal, in-order traversal, pre-order traversal, and post-order traversal. So this is the set of operations which we can perform here, and here we have case 1 as the number of values we need to insert. We are entering here like this itself. So recursively we're going to call within the for loop. So those many number of times the values with this will be inserted, and each time the data will be inserted by the user. And if in case if we want to search for an element, the option 2 is a search for an element. We need to provide the data for which we are looking for. So it will call the function search with the root as the starting address and the data to be searched. And third option we have is the element to be deleted. So here it is going to search the element same way what we are use the search operation. The same way it is going to search for the element and delete that particular element. Of course, in the question the delete operation is not there, so you can see the code later. And the next we have is a in-order traversal. So option 5 is pre-order traversal, option 6 is post-order traversal, and 7 is exit. So now we can see the output of the program here. So this is the output we have. So all the options is displayed. If I go for choice 2, the element to be searched, and this is how the output looks. So these are the different options available. So when we traverse the given tree, this is the in-order traversal, and we can go for pre-order traversal, post-order traversal, etc. Thank you.